Hello. You guys want to get started so people are taking a seat? So, thanks again for coming tonight. So just before we start, a few quick announcements. So we have the HBase meetup next Thursday. It's going to be at Internet down at Redondo Beach. So that'll be great if you guys can make it to that one. And on February 10th, we have this next Spark meetup. That's also going to be a good topic, and that's going to be out here at class campus. So with that, we're going to do a few giveaways at the end. We're going to pay attention to Erik and probably going to ask some questions. We have some good books and t-shirts as well. With that, let me introduce Erik. So today Erik is going to be discussing operating Hadoop in a multi-tenant environment. Erik is a solutions engineer at Datameer, where he guides customers to do end-to-end analytics on their platforms. So, for a round of applause for Erik.
Okay, thank you. Thank you everyone for coming today and visiting and enjoying our presentation here. So actually, just before I start the presentation, we have a lovely little game. So if you brought any business cards and you dump them in here, you'll win a potential prize at the end here drawing. So be sure to do that. Okay. So without further ado, I am Erik Halseth, a solution engineer, part of Datameer out of Los Angeles here. And I want to kind of briefly uncover the topic around, well, you have this wonderful thing called Hadoop, and it's the growing ecosystem and all related parts around it. And then you have perhaps an organization with many, many different business users, and you want to attack many different kinds of problems. But the issue is, how do you manage the friction between all of this? And so I hope that by illuminating what Datameer kind of brings to the table, we can actually kind of cover and bridge that gap there. So just very simply, Datameer vision is it's deadly simple, right? So we want to make big data analytics very simple for the regular business user in any organization, right, across all vertical industries. And I'd like to think that one of our core tenets is really the whole concept of democratization of analytics across Hadoop, right, across many different data sets for your end users, those who are very terribly familiar with the context of your data, right? So just very quickly, Datameer at the highest level kind of allows a user to actually govern the entire lean analytics lifecycle, as we like to call it, right? And what does that really distill down to? It's really three pillars. The first, which is logically speaking, you have to do the data integration. You have to identify your question, right? And then for that question, you have to say, well, for that particular question, I need to have a mix and match of different data connections, right, to different data sets. And that's essentially a portfolio that kind of could potentially speak to my business question, right? And so once I provision those things, then I want to do data integration, right? So that's simply at the very highest level, doing the importation of that data into your Hadoop cluster, right? So we allow several different avenues, one of which is to physically move your data into Hadoop first, or actually just, in some cases, you may just want to have the data residing on those third-party data sources, right? Especially if you have time-changing dimensions, right? In this case, it's simply just a pointer. You're just moving the data physically as a data link at the moment of computation at scale via Datameer. And then all of that data temporarily resides and then gets thrown away at the end of the job. And so once you provision all of those data connections, you've moved the data, or you actually just set up the data links to all of the different data sets, right? Now you're actually ready to do essentially point and click analytics. So what does that really distill down to? Well, we operate from a completely different paradigm. So it's all about ELT, right? It's schema on read, and that's the flavor of the day, right? We want to be able to allow the business user to load in all the raw data sets at any given time and massage them through the spreadsheet UI. At the very end of the analytics life cycle, right? We say, well, once you've scaled that out and you're satisfied with that design flow in that spreadsheet UI, you've kicked that off in your Hadoop system, now you're ready to roll, right? And you can surface those insights up to these lovely visualizations, right? So we also have another package called Smart Analytics, because as part of this whole big data revolution, for me, it's very often synonymous with machine learning applications, right? And building those machine learning workflows. So we've distilled down this into a package of 4 commonplace machine learning algorithms, in which we can discuss in detail much later, right? Which will enhance your sort of data discovery process. So I've talked in that link just very quickly what Datameer is in terms of its capability set, or how does it sit here. So we've talked about data sources, right? So you serve to protect your portfolio of a mix and match of data sources and connections, right? So we have modeling there. So all of your work with regards to machine learning, predictive modeling workflows, it's not lost in vain, right? We can simply re-import that via VMML, right? Pick your flavor of the day, R or SPSS, right? We can import all those models via VMML and store them at scale. For security, of course, we have all the common culprits, LDAP, verbose, monitoring and scheduling. We have that internally, and for us at least, we are pretty much agnostic across all the distributors, if you're very curious. And of course, we do support virtualization and VMware here. It's just one example. And last but not least, Datameer sits sort of wonderfully amidst all this chaos on top of Hadoop, just natively. So just very quickly, here's the classic business analytics data flow, which you have all of these separate data marts, and you're doing these traditional ETL processes, and your business users are asking one question, right, on a dynamic basis. Or maybe if you multiply that by 10 or 100, then you start to get into this mess where you set up this data integration pipeline, and you set up the schema, and at the end of the day, it doesn't answer your question, time is lost, money is lost, etc., right? We want to be able to kind of circumvent that process and say, well, let's just throw everything in raw. Let's operate from more of a schema on read paradigm, right? We allow the democratization of your data analytics with your business users on top of this spreadsheet UI, right? And then all of that is sitting just one-to-one on Hadoop. So Datameer, how's it installed? It's installed obviously on premise, right? Or it can be installed on the cloud. So I kind of ran through the gamut of just very quickly, what is Datameer? What is its capability set? How does it sit in your environment? What's the structure and fundamental paradigm that Datameer kind of brings? But the problem here is that if you notice, with the growing Hadoop ecosystem, you have a multitude of execution engines. I mean, just name it, right? So you have obviously optimized MapReduce in the form of Tez, or some specialized memory engine. It could be Spark, or it could be Technology Z in the coming years, right? Who knows? There's all of this mess. And so the problem as we see it is that typically you have this data analytics funnel, as I like to call it, and you use sort of these logical sequence of analytics, right, going down this particular funnel, right? And you'll notice that there's an inflection point at which here you start to say, well, I have a hypothetical 10 petabyte data set, and I can start by, let's say, filtering it down, maybe saying, well, I really don't need this portion of the data. I can actually go in here and say, well, let's actually cook this down a little bit further in terms of grouping, second level, third level grouping efforts, and then finally aggregate that data down to something on the magnitude of, I don't know, on the magnitude of gigabytes, right? At which point, you may want to consider throwing in memory processing, right? Because you certainly have enough memory on the magnitude of gigabytes, right? So there's this inflection point that you have to cross, right? And it may be meaningful to spin up, let's say, a Spark-like engine or something in memory for your data set when it's at that particular size, when it's past that inflection point, right? And in addition, you could have other kinds of things thrown into the process, such as iterative-based algorithms. Machine learning comes to mind, right? And at the very end of this, you want to present those results, and typically, and in reasonably fashion, you have something on the magnitude of hundreds of megabytes, right, that you want to kind of slice and dice and present to the end user, right? Actually, I had a very interesting conversation with someone a few months ago about this, and I explained to this person that the concept of this data analytics funnel, how it kind of narrows down as you complete your lean analytics cycle, right? He said, well, what if you have something sort of like a Cartesian product, right, which kind of explodes your data set, right? Well, in most cases, I would say virtually in most cases, yeah, it will temporarily explode your data set, so you start to see the funnel kind of grow widthwise. But ultimately, your only concern with regards to your question may be a subset of those Cartesian pairs, right? So we have this dichotomy of, well, this big data, right, in which you may not have enough memory, right, in which you're concerned about maybe the fidelity of it, accuracy. And then you have this other side, right, in terms of, well, I can get it down to maybe on the magnitude of under terabytes in terms of gigabytes or megabytes, and that's reasonable amount of memory or space for me to fit data sets and throw different kinds of analytics with respect to in-memory processing or machine learning, for example, right? So you have this dichotomy, and then how do you deal with it, right? So there are different kinds of characteristics about your data, right? And you definitely don't want to just say, okay, given the classic MapReduce paradigm, you don't want to essentially use that paradigm as an execution engine and just throw it against every single analytical job, right? It's not terribly feasible, right? Because you may have cases where you need to have that iterative processing, or if you filter down your set to a reasonable size data set, right? You may not want to use another iteration of MapReduce because there's a lot of latency and overhead in actually initiating that job, right? So you may not want to use a cruise ship when you can just use a bicycle to complete the process. So in this case, what we found with a subset of our customers is that, interestingly enough, we've tracked their usage of all of their jobs, and we've actually sized, okay, we've completed these jobs, we've counted those jobs at particular buckets of data sizes. We found that for those that kind of range from 10 to 100 megabytes, you have quite a bit of latency there. That's because, in this case, they're running into the classic MapReduce paradigm and all of that friction of latency and spin-up, which you can't possibly take this and expect reasonable performance, right? Because there's just so much, it's just so small. So you may have to consider using something entirely different. But the fact of the matter is, do you want your business users to recognize that and actually handle that and actually take a facet of your job and say, for this subsection of the job, I'm going to actually throw this to this other execution engine. Whereas, well, you may have other execution engines coming over the horizon, and now you have a total mess and kind of managing all of this chaos, right? So our solution, very simply, is to actually recognize the fact that, yes, there are these points of inflection where your data set reasonably gets down to, something on the magnitude of gigabytes or megabytes, in which you can start using those kinds of characteristics in terms of data sizes or in terms of the fundamental inherent characteristics of that one part of your analytical job, be it machine learning, be it something else, right? So we've broken it down in terms of this, again, this funnel concept, right? So at the very top, we have optimized MapReduce, right, which speaks to something on the magnitude of terabytes or petabytes, right, in which you need to actually you have enough data which you can parallelize against those large data sets and aggregate down to something that's particularly relevant or interesting for your business question, right? At which point you may want to say, well, there are certain parts of other jobs where I'm actually joining this, let's say, relatively small, let's say, master table about my customers, and it has all of this unique identifying information about all my customers. In that case, it's small enough to actually just run in memory, right? You don't necessarily need to spin up an optimized MapReduce framework for this, right? So there are different points, different facets of the job in which just best optimized, because it's no longer a sort of a yarn paradigm in which, yes, now you have these efficiently shared resources across multiple jobs. Well, we've taken it a step further and said, well, within the job, there are actually still further points of optimization and performance squeezing, right? So just very quickly, from an architectural perspective, this is how sort of Datameer is broken up, right? So I talked at length the capability feature set at a very highest level, right? So you have data integration, you have the spreadsheet, which is sort of a mapping to doing your analytics, right, at design time, and then scaling it out. And then, of course, you're taking that resulted set and using the visualization. What happens underneath, right? So, you know, I hinted, right, you have one analytical job which is composed of different assets, right, different kinds of activities. And that's essentially really a DAG, right, from a computer science perspective, it's just a directed acyclic graph, right? So I'm coming in, I'm actually importing or pointing to this one raw data set, I may be filtering and then doing some aggregations, and then in the meantime, I'm actually importing or pointing to another raw data set, and I'm joining at some point further down the line. And there's some, if you look at it from a graph, a direct acyclic graph perspective, you'll notice that this line of analytics doesn't really depend on this, right? So there's some parallelization that you can take advantage of and leverage, right? So from that perspective. And then on top of that, we have this thing called Smart Execution Engine, right? Which it actually speaks to another point, right? So you'll notice that we have a multitude of execution engines on top of Hadoop. You know, what is what, which is which, what should I use it against, what use cases. And at a job level, or intra-job level rather, there are different points, entry points for that execution engine to be best placed, right? And so the smart execution says, well, given a job and its characteristics of each part of that job, well, what's the data size? What's the inherent processing? Is it machine learning versus aggregating a high fidelity data set, right? It takes those parameters into account and says, well, I'll smartly choose maybe a MapReduce type framework or something in memory, right? And then everything sits on top of Yarn, and now we're happy. So you'll also notice that in terms of the workflow, right? So I spoke at length. If you ask a question, I can actually dynamically just push in raw data sets. It could be a multitude of these raw data sets. And we're operating from the ELT TTT paradigm, right? And so everything's pushed through Datameer. You go through this design flow, and once you're satisfied, you scale this out. But as a business user, as an end user, I don't really care which facet of that job is being taken care of from which engine, right? So you have a multitude of options, from optimized MapReduce to in-memory to something in the future, right? Because the space is still growing. We don't know, because there could be a stealth engine coming out in 2 years called Technology Z that could be the glowing brilliance of the future in terms of analytics, right? We don't know. So here's a brief look at the DAG processing, right? So if you look at left versus right, there are points. You can think of that as one analytical job, right? Which is composed of different kinds of parts of that job: filtering, aggregation, grouping, series multiplication, what have you. It could be machine learning algorithms. But we say, there are dependencies or non-dependencies that we can take care of and we can take advantage of, right? So we break that down in terms of DAG processing. And of course, right, each analytical job has many parts, as I said. I've given you, I've littered a few examples there. And you can kind of see it from a visual feedback perspective if I put on my administrative hat, right? So I can clearly see that here's an example of I've run one job here, and I see that there are different parts of the job that ran from time T1 to time T2 and so forth, right? And I can see that if I click visually on one of these segments that, hey, the smart execution actually chose this execution engine to best handle this type of this part of the job, right? And you can kind of see that broken out. And I'll actually demonstrate this for you. So I think that's very, really cool. And at this point, let me actually just pause here for any kinds of questions, lingering questions before I jump right into the demo and demonstrate this. Yes?
So if you're coming from more of a relational database background, looking at this, it seems like the execution engine is somewhat similar to what you might think of as like a Could you hear me?
I'm sorry, could you ask the question again?
So if you're coming from a more relational database background and moving into some of this, the immediate analogy that occurs to me that I want to ask you if it's correct is this execution engine something somewhat similar to what I would think of as like a cost-based optimizer that is dynamically making decisions about how to organize or how to allocate the query and kind of the order to execute things and what you're talking about. You can use MapReduce, first rows kind of thing, all that stuff.
Yeah, so I think you hit it on the dot. I think conceptually it's very similar, right? Because you could have one job that's composed of many different kinds of working parts, and each working part is best handled by a particular engine, right? And like you said, right, just like a cost-based optimizer, it has to take into account certain characteristics, right? In the context of Hadoop execution engines and Datameer, that it would typically be your data size, right? It would typically be the quality or the what that part of the job represents. Is it a machine learning algorithm, which by implication needs to be running in memory because it's an iterative process, for example. So.
Okay. Here. So is this treating the schema and layout data as a fixed thing and just figuring out how to get it, or does it say, I think we should take that data and move it into an in-memory process? Is that how we should test it?
Yeah. So that's actually a really good question. So let me try to clarify that. So you're essentially asking if I have this data set of this particular size versus this data set of another size, where does the magic happen? How does the magic happen? Is that yeah, so essentially, thankfully it doesn't happen in the brain of business users, or we go crazy when dealing with this, right? Especially when you have upwards of 10 to 20 different parts of one analytical job, right? It become quite complex. So smart execution kind of comes into the picture and saves the day and says, well, I'll automate the intelligent decision making behind that. So. Any more questions before I jump back into the demos? Sure.
So let's say the system decides, this data doesn't belong over here, it belongs over here. The translation time and that sort of thing could be extensive for figuring out how to redouble things. Do you schedule that and do it late at night, or do you do it along with the particular query for a report, or how do you do it?
Yeah, so if with regards to smart execution, it's essentially squeezing optimization and performance at the intra-job level. But you can actually, if you schedule that job at that job level, that you need to actually run it at 8 p.m. every night, right? And obviously you can't have it in such a way where this part of the job says, oh, let me run this a week later, right? That's not feasible. It takes into account the job level scheduling as well. You can't break it out like that, unfortunately you can't at this time. Is there another question in the front?
Okay, the question is more like a follow-up. Can you reveal some of the decisions that the system is making on how to process the data? That's more like the question that's going around is like, we all kind of know how to optimize our relational database works. So we have anything like, they used to be like, I don't know if people remember, but they used to be a rule-based optimizers in the earlier version. And now they're more cost-based, like there are statistics and other things that based on that, optimizer will go and make decisions. They're going to give us more internals of how you guys decide which way to go based on what.
So you're asking in the past, there was a plethora of SQL relational optimizers, right?
Yes.
That kind of helps you say, oh, I actually need to change mechanics of this query to squeeze out additional performance, right?
You can actually define things. You can just say, use this type of a join versus this type of a join.
Yeah, and then you actually further add it to that it's now statistical-based learning that kind of helps you, right, and guides you, right? Yeah, so essentially, so today, it's very similar conceptually, but it's geared for Hadoop execution engines on top of Hadoop, right? It's very similar conceptually, but it's for a different paradigm. It's obviously for a different system in this case. Okay, cool. Okay, so what I want to quickly show you here with the given time is two brief demos, right? So this is about campaign analysis, and what I'm looking at is the window into the Datameer application simply done through a Chrome browser, right? And right here, I'm looking at different assets, in this case, these workbook assets, which contains the heart and soul of all my analysis. So I just want to quickly just look at just one sample, right? So here's this campaign analysis, and let me just log in for you. Right. So I have two particular workbooks, right? They're essentially equivalent to analytical jobs, right? And I want to just briefly take you on a journey with what the data actually looks like and what kind of analysis I'm doing. Okay, so I have this raw bank data set, and really this is just, we call this a smart sample because we're operating from an ELT read-on schema paradigm, right? Because we want to be able to allow the business user to design the analytical flow at speed of thought. And here, we can use the flipsheet capability, of course, to look at this from a data profiling perspective. And obviously, I have data characteristics such as age, job, other kinds of features with regards to balance, housing, and ultimately, right, I have a particular interest in looking at loans and the propensity for actually applying a particular loan for a group of customers, right? And they all have these different features, right, in terms of campaign durations. And I'm trying to launch this marketing campaign, for example, to move these customers to a certain kind of loan. So now that I've established the concepts of the data and I've looked at this flip sheet, now we can come back here and say, well, based on this, as a business user who's really familiar or intimate with this data set, I can come in here and do a multitude of different kinds of analytical moving parts to this, right? So I can extend this. I can say, well, let me count the number of default loans, right, across my population sample. In this case, I'm actually referring to this group by. I clearly see that there's this group by analytical function, and I'm actually doing just a simple frequency count, right? And if I click here on an empty column, if you're just out of curiosity, right, it exposes a multitude of different kinds of analytical categories, each of which is just naturally scaled out, right, on top of Hadoop. And then Smart Execution says, well, for this particular execution, I know for a fact that you're using these analytical functions. Doesn't matter, right? We will take care of all the automation and selection of that, right, in the translation. So as you can imagine, I have a default type set up. Maybe I'm just counting and grouping by housing loans, right? So a lot of these, as you notice, by nature, are a lot of aggregation type activities. You'll notice that I'm continuing to do this up until the point where I have this one part of the job where I'm beginning to examine this from a clustering perspective. And of course, this is essentially iterative in nature, right? So obviously, maybe I knew something about the context behind this data, and I knew that for a fact that time between campaigns, number of calls, whether the campaign was successful, is important for me in doing this sort of clustering or segmentation, right? And by default, I just have 3 clusters here. And I can update the sheet or create an entirely new sheet. And I have all this wonderful numerical data, and I can actually look at this from a flip sheet capability, right? And I have all of this broken out into 3 different distinct groups. But I know for a fact that yes, this is clustering. This is necessary to run in memory, right? I would kind of intuitively require that. Here, I'm actually just doing more types of aggregations, but this time from more of a numerical perspective. So I'm actually doing averages, right, across all the 3 clusters I generated, and so forth, right? So as you can imagine, that may call for maybe a MapReduce type of framework. So if I now that I've established the landscape of my analytics process, and I know for a fact that if I look at this, right, from a data lineage perspective, this is basically abstract representation of my directed acyclic graph, right? That means I have a flow of analytical activities. Each tree under that each tree branch under that flow may or may not be dependent on the others, right? So obviously, the things that I've done under default, that doesn't depend on any of the use cases or analytical activities I solved under highly educated or for clustering, right? So I can see that clearly there are some branches and some opportunities for parallelization. And each node you can think of as just, for me, I can call it as a facet of that analytical job. And smart execution will actually recognize that and say, hey, for this facet, I would recommend automatically this particular engine. And I'll show you just that, right? So if I actually navigate back to the browser here and say, well, I have these 2 particular workbooks. One that I fixed for classic MapReduce, the other one called mixed mode, which I fixed to say, well, use smart execution and tell me what you come up with, right? So I can, from this interface, I can actually kick off the workshops if I wanted to. I can, before I even kick off the workshop, I can even demonstrate the governance, right? So I can obviously manually, dynamically click this off. I can do this in a scheduled, tried and true approach, or even a data-driven approach, right? This is kind of interesting because I think I spoke a little bit at length about time-changing kind of data. And so if I know that my bank data is changing in time, I can specify a time role that says, well, only kick off this analytical job if my data, let's say, becomes stale after 3 days. And that may be a business rule I'm very familiar with, right? Data retention just speaks to, well, if I'm going to democratize all of these analytical jobs in Hadoop across an army of users, do I necessarily want to keep the last 100 results or just the last 1 result, right? We can actually save results in time-based partitions. And this just says, well, am I, for the purposes of my question, my business question that I'm asking, do I really need to retain the results of the things I did in default or under a housing loan, or do I necessarily care about the results from clustering, right? Maybe not. By default, I'm just keeping everything, but just take note that the ultimate performance bottleneck in Hadoop is just writing back and forth input and output, right? So you can save performance time here by weeding out unnecessary things very much early on. So I can actually start the calculation process and just say scale it out, right? And now it's actually kicked off. I can see that this other one's at 41%. I can come in here and look at this from more of an administrative perspective. So I can come in here and just show details, and this should tell me that there's a particular job ID that was assigned to it. I can view this as at 47%, but I should also see that this other job here that I kicked off, if I look at the details, that probably will run definitely faster than the other one because it's using, in this case, smart execution. It recognized the fact that the different facets of that analytical job that I just showed you, the housing loans versus clustering, for example, they would require optimally different kinds of execution engines. And so it looks like it just finished. I can click on the job ID for this one, right? This mixed mode that's using smart execution. And I can see different kinds of I/O immediately, just different kinds of I/O benchmarks, right? So in terms of the input records, the input size, output records, etc. And I noticed that it ran for a duration of 31 seconds here. I can come here, right? So I subtly intimated that, hey, there's this visual feedback mechanism called a job graph. What is this job graph telling me? It's really saying that all the wonderful different facets of that analytical job I showed you, calculating or aggregating the highly educated, counting the education, the ones who have education, right, or do not, the ones with personal loans, the ones with defaulted loans, and so forth, right? And you'll notice that if I click visually on each of these different facets of that analytical job, here, under task details, smart execution recognizes for the fact that, yeah, based on the data size and characteristics of this, I selected optimized MapReduce for you, right? And here are some of the I/O benchmarks, marking statistics associated with that. If I click on this, for example, I know for a fact that this is going to be associated with the iterations of my clustering, right? So this is just going through the exercise of actually segmenting out my different customer populations in terms of groups A, B, and C, as I showed you. And this says, well, I know for a fact that I need to keep this iterative running in memory. Let's just smartly select small job execution in this case. And of course, you have the wide variety of I/O benchmarking statistics associated with that particular facet, right? And I can even actually just toggle back here and show you that this is actually just still running. It's at 59%, right? So this is, and obviously this is not the way to go if you're going with the classic framework of just MapReduce and blindly throwing it on every single facet of your job, right? Be it machine learning, be it aggregation, or whatever it may be, right? So I think this is really important in terms of comparing the two approaches, and you recognize that, hey, there is this wonderful opportunity to squeeze out even performance at the inter-job level. And by the way, the end user ultimately doesn't even care about this, but it's actually occurring in an input. So with that, I've actually run the full gamut of the presentation and demo, and I'm just going to pause here for any questions.
Hi, can you go into details and describe the differences between the configuration of the worksheets, the mixed mode and the predicts mode?
Yeah, absolutely. So here, if looks like it's still running, obviously, but if I come in here and show you the configuration for the classic MapReduce framework, right? So I can clearly see, well, I enforce that right here by saying I'm taking this custom property called das.execution framework and saying I'm enforcing the fact that you need to run classic MapReduce, right, for all of the different facets of that analytical job. And as you can see, it's still running, obviously, right? Whereas if I look at this from a comparative perspective, looking at the configuration for my mixed mode, right, it has a different property. I said that I'm enforcing for the fact that, okay, I know for a fact from all those data, right, I know for a fact that I actually configure the data in such a way where I know for a fact that the aggregations, all the aggregations typically, from a common perspective, occur after 4,000. And so I'm actually overriding the threshold and saying, well, anything. Remember, I talked about that inflection point. Anything over, let's say, equal or over 4,000 records here, right? You actually use that characteristic and say enforce aggregations, right? So that's actually optimized MapReduce for those types of aggregation activities in that particular job. And everything else that kind of falls under it, just recognize for the fact that that should just be small job execution, right? For anything underneath that. So you can actually enforce this or actually just leave the defaults as is. But I just did this for comparative purposes. So.
Can you show us what the defaults are or the list of those
Yes.
properties?
Yeah, so I think the defaults would be, I think in terms of bytes, I think it's about around a gigabyte, I think. So.
No, but first, can you show us what the properties, the custom properties?
Yeah, so
Do you have a list of them? Like here are all the custom properties?
yeah, so these are the custom properties at the job level, right? Obviously, there are other custom properties if you're interested, right? So I can come in here in the administration perspective and say, well, for this particular Hadoop cluster, I have these associated Hadoop properties, right? So this is just blindly all jobs, essentially.
These are the default?
Yes, these are the defaults for every single job. Not at the specific job level, but you can override that obviously. Any more questions?
So we were looking at the chart before about the various architecture components you have, and notice you have the execution engine below that, several different possible data sources of execution engine you can go to. And then above that, you have the visualization components and some of the GUI things you can see.
Yeah.
Can we decouple some of that? For example, is it possible for me to use another client like Hello or something else to make calls directly to the execution engine? Or do I have to use the whole stack together and I can't kind of go in the middle, so to speak?
Yeah, that's a wonderful question. So you're not wedded to the entire stack, right? If you look at it from the architectural perspective, you're not wedded to using all three of those things, right? You may say, it's important for me to actually have my end user use integration, right, and the analytics inside the spreadsheet, right? But I may not necessarily want the visualization layer within Datameer. I can actually set up export jobs, for example. So there are multiple avenues. I can actually govern the data movement into Hadoop as well as out, right? So I can actually set up export jobs here and say, well, through this wizard-led pathway, I can specify a particular workbook. Maybe I care. Maybe I actually care about the results from my workbook that I just ran, right? Under applications, under this SX demo, under data mining, for example. I could say that for this mixed mode job, I actually care about the results from here. And I can click this, select this obviously, and then point to a particular sheet that's important for me, right? So these are the different facets of my analytical job. Maybe it's important for me to actually look at clusters, or maybe perhaps the metrics around the clusters, right? Here's a little preview. I can go through this and specify a connection. And this connection just really says, well, where do I want to push the resulting data set downstream to some system, right? So just choose your flavor of the day. It could be MySQL or whatever, right? In addition, if I actually should show you here, so if I look at this from now that this is actually finished, I can show the results for you. And actually, I can actually point to a particular sheet that's actually fundamentally crucial for my question, and say, let me just download this, right? So I can obviously do this from an ad hoc perspective and use any of my own desktop tools to kind of like peer deeper into the data, right? So I can obviously download this as a delimited CSV format or a tablet extract, right? Any more questions? Yes.
If you are creating some temporary storage for this step, how do you define the retention rules and things like that so that you don't load up the storage state you have it going?
Yeah. So if you're really concerned about managing data capacity with Hadoop cluster, the user has several different opportunities to do just that, right? So I think I wasn't direct enough and explicit enough, but if I come in here and show you the configuration for this particular job, right, this mixed mode job, here's some of the data retention, right, in terms of managing the resulting sets, right? So I could fiercely pick this up 100 times, but do I necessarily want to pass the results, right? In addition, remember, each analytical job is really just composed of many different types of sub-tasks, right, or facets, as I like to call them. And do you necessarily need the resulting set saved and written into your Hadoop cluster with regards to default analysis or counting of thousand ones? Maybe not, right? You have opportunities for time savings. And of course, I think it's important to actually go back and really ask yourself, do I really need this for my question? And ultimately, if I don't need it, then there's actually some time savings in terms of writing back to Hadoop, right? So, any more questions? Okay, thank you all. I think that pretty much ends my presentation and demo. It was truly a pleasure. Thank you.
Some giveaways. So, this is t-shirts and books. So we're going to do some giveaways. I'm going to have Erik ask some questions and maybe they can make some of the good books so you have about it.
Okay. So I have here a set of O'Reilly books, each of which could be a potential prize for anyone willing, a willing participant in the audience. If you have any particular questions that you would like to actually add. Or actually, I'll ask the questions. I think that's a fair deal, right? I mean, first of all, I'd like to get a gauge of in the audience of what some of your takeaways from the presentation, or did it spark any other related thoughts from coming here? So just very much interested. Just kind of going through that. Okay.
It made me start to think about the various kinds of execution engines we have, and the possibility of writing multiple execution engines at the same time. Made me think about varying execution engines and the possibility of running multiple engines on the same Hadoop cluster at the same time, or not just Datameer, but possibly various products at the same time for varying purposes. So,
hey, give us another book. Any other thoughts that come to mind from any other audience member? Sure.
Just one question. So I missed the presentation. Is there a way to access the presentation part of this from somewhere else?
I'll just put it on the slides. I could share a slide, right?
Yeah, I could share a copy of the slides. No,
So I'll put the slides up.
Thank you.
sure. Any other diabolical thoughts that kind of sparked up?
You guys are a shared environment. How do you manage that if one user doesn't install the entire class regularly?
I'm sorry, could you repeat the question?
You guys are a shared tenancy. It's not like one user that uses you exclusively. So how do you manage that part where one user can go and start a job that can kill everyone just because you configured it?
Yeah, so that's actually a really good question, and the whole application is really actually. There you go. No, that's actually a wonderful question. So the Datameer application is really geared for multi-tenancy usage in an enterprise environment. So as you can imagine, any of those workbooks, right? A workbook is really equivalent to an analytical job. You may not want all of your business users running that particular job, right? You can assign user role credentials. You can assign them group credentials, right? You can actually blindly say no one can touch this in terms of executing this job besides the administrator for the application, right? So you can set those kinds of roles, and you can mix and match them hierarchically if you want. In addition, if you're actually worried about, well, I don't care about governing security on a per workbook, per analytical job basis, but I'm actually worried about maybe provisioning, let's say, column level security, and actually maintaining that throughout the entirety of that analytical job's lifetime in the Hadoop cluster, and you can do that as well. So you can say, here's a raw data set that I've loaded in, and I only want users Alice and Bob to actually do some analytical activities on the first 3 columns of this data set, and you can actually enforce that, which is very, very cool. And we actually have 3 t-shirts as well. So, does that help answer your question? Okay. You have a question?
Actually, I have a question here.
Okay.
I would expect that in a case where you've got not so sophisticated users, the big hazard is not so much looking at the wrong data set, but trying to do an operation that ends up taking 17 years, and they just can't tell the difference between 17 minutes and 17 years. So, do you have any special way of handling keeping people out of that swamp?
So could you please clarify the first part of your question in terms of the
Well, it's sort of a follow-up to what he was asking about. One kind of thing you might want to say is, don't run your slow report at the same time all the other important slow reports are running, because they'll jam them up. Another kind is don't look at this secret data over here that you're not supposed to see.
Sure.
Those are pretty cut and dry, easy to define things. How do you say Bob is not allowed to run jobs that take either 3 hours to run or 300 years to run?
Yeah, that's actually
Clearly, nobody can run the 300 years.
so that's a really good question. So fundamentally, Datameer, when it actually launches, pretty sure it's one analytical job or workload in Datameer window, right, on your Hadoop cluster. Yarn just considers it as one single application, right? So if in your enterprise environment you have a Hadoop administrator and just pick your favorite data, works or other or whatever it may be, there are of course Hadoop-wide cluster settings that take care of that, right? So if one job is sputtering, for example, and one particular task is sputtering for a long time, then there's of course a particular setting that says, well, if it times out for this amount of period, just kill it, for example. And so we for some of those situations, we default to the Hadoop-wide cluster settings, and we work with that.
So, just to iterate on what Erik mentioned, Hadoop has got the scheduler-based settings, so you can configure a capacity-based scheduler, FIFO-based scheduler, file-based scheduler on Hadoop. If you have specific users or you want to be consuming a lot of the users of cluster, but you don't want them to use, you can set up a capacity-based scheduler with different priorities and assign them to that particular set of yeah.
There's a shirt there.
What's up?
There's a shirt, doesn't he? Oh, he has one. Okay. Oh, okay.
Both are small, so.
I believe someone else had a comment or question in the class.
Well, among many jobs that I have seen, a lot of resource is wasted on analyzing data that has not changed or has only partially changed. Is there a mechanism in Datameer that would detect data that's really changing so that the second round of job of the same report would run faster?
So let me try to clarify your question, or re-clarify rather. You're asking about how does Datameer recognize that for a particular analytical job that points to a data set that has a time-changing dimension? How does it recognize?
The underlying data is only partially changed. Is it intelligent enough to detect that certain data components remain static, certain data components has changed?
Yeah. So in terms of with respect to time, right? It will recognize it. But with respect to something else, let's say an address change for one of your customers, right? It won't go out and scour the whole dataverse in let's say your schema and say, oh, there's a change here, I need to actually update that, right? So that's actually more of an integrated sort of pipeline activity, right? The way in which we propose our paradigm, it's more about a big data discovery. So so for those scenarios, it would be up to the user to say, upon this question, do I want this data set or this data set at the given time, right?
Yeah, earlier someone made a comparison between this and the database cost-based optimizer. So one thing that cost-based optimizer does is to create more efficient execution plan based on the knowledge of data, based on like data volume and efficient indexing and things like that. So it's like there's a certain layer of building intelligence.
Yes, there are multiple layers of building that intelligence, but we obviously haven't gone that particular route. So, but thank you for sharing your thoughts. Sure.
You want a book?
Any other final thoughts or questions? Brain teasers? Okay. That's it. We do have a drawing here, so this would be for a t-shirt drawing. So we have a few business cards here, so I'll just randomly pick one. Josh Gruber is the winner. Right. So Kim, we have t-shirts here. Okay. Josh Gruber. And I believe that's it in terms of prize selection. If I'm not mistaken. Oh, there are two more. Okay. So, let's see. Okay. We have David McDuffie. Please rise. We do have one other person here, Kim Shlimi, but she would be cheating because she works for the company already. So there you go.
What size is this?
Medium
What is it?
and a small.
They're medium and small.
What is small? No, small.
All right, I guess all our prizes are completely depleted at this moment, so I guess we can close there. Okay,
Thanks for coming, guys. See you next week.
thank you.
All right, smash. Until next time.
Thanks a lot. Thanks for coming.
I